Okay, so the idea here, guys, that we'll practice a little bit of kind of vector component stuff, a little bit of our kind of review a little bit of V equals D over T and displacement and that kind of stuff, but in terms of a more practical application. All right, so you're going to be given a topographical map, okay, that will come in 3 pieces, and it will look like this. All right, so it's a map of part of Jasper National Park, right? And what we're going to do in this activity is we have to plot our way from the start to each one of the points. So we'll go from start to 1, and then from 1 to 2, and 2 to 3, 3 to 4, and then we end here at 5. All right, now you have to plot your way around in a realistic manner. You do not have a jetpack, all right? You are on foot. You don't have a boat or anything else, just your feet, 1 foot in front of the other. Okay, so you got to kind of plan how you're going to get from one place to another, and then we'll do the kind of vector analysis of that as well. Right, so there's a little bit of kind of real world stuff in here, and then a bit of the kind of practical application of vectors as well. Okay, so your assignment is to plan your route to each of the destinations. When doing so, you have to consider several things and obey some rules. Okay, some things to consider are that conditions in the mountains can influence the speed at which you travel, especially should you get adventurous and decide to leave the trail. Okay, there are trails on the map. They are indicated by dotted lines. If you leave the trails, travel becomes different. In some cases, it becomes more difficult. In other cases, not as much. Right? You also have to look at things like how steep an area is. Now, how many of you have ever used a topographical map before? Okay, so it's like a dwindling number because I just Google Earth it. Yeah, wonderful. Okay, in a actual map, okay, in a topographical map, you see these lines here? Okay, each one of those denotes, I think it's like 10 meters in reality. All right, any place where the lines are stacked really, really close together, like right here, that's a cliff. Okay, because each one of them is 10 meters and they're right on top of each other, so it's straight up. Okay, anywhere where they're spread further apart, it's less steep. So this would be like a gentle hillside right here. Everybody follow? So you have to plan your route accordingly. This is not a viable route for you to get from here to here just by going like this. Oh, I'll just do that. Well, that's one way to die. Okay, I mean, that's, take one step. It's a big step. Right? A long way down. And it's not the fall that kills you. It's a sudden stop at the bottom. Keep that in mind. Okay, so you have to plan where you're going to go accordingly. And oftentimes what you end up doing is going a little bit out of your way. Like maybe you have to kind of go around, okay, and then kind of work your way down and kind of do some switchbacks and things like that, okay, across places that are steeper, right? So I probably want to avoid that spot where the creek is, okay, and then maybe work my way back down to a less steep area, all right? That's actually what most trails do. Very few trails, smash a straight path from one place to another. They have to follow landforms and go around obstacles and things like that. Okay, so that's something to consider, okay, when you're planning your route. Other things you have to consider is, well, stream crossings. Okay, depending on the time of year, if you're doing this in like late June, early July, those streams can be raging torrents, okay, that can be quite difficult or dangerous to cross. So you have to prepare yourself, okay, if there's no bridge. If you're on a trail, it's no big deal because on a trail there'll be a bridge. If you're off trail, well, then you are wading across and that can be difficult. All right. So here are the rules. Rule number 1, altitude affects speed. So if you are on a trail below the tree line, that's the green area is below the tree line. Okay, so you guys know what the tree line is, right? Like when you look out the mountains, you see where the trees end. That's the tree line. Okay, so if you are on the trail below the tree line, you are in the green area on a dotted line. Okay, you can walk at 1.5 meters per second, which is actually a pretty good clip if you were carrying a pack. Okay, above the tree line, if you're on the trail, you can only walk at 1.2 meters per second because as you get higher up, there's less oxygen and you don't walk as fast. You tire more easily. Okay, so if you are on a trail and above the tree line, you can't walk as fast, and that's going to influence how long it takes you to go places. Okay, number 2, the Bushwacker Rule. Okay, off-trail speed. So if you go off-trail, and you'll have to because I've made it so that you have to, okay? At some point, you will have to go off-trail. If you are below the tree line, you will move at only 0.75 meters per second because, well, there's no trail cleared and you have all the undergrowth and trees and whatever else in your way. You go a lot slower, okay? If you are above the tree line, it's less of a big deal because there's no what? Trees. So it doesn't significantly slow you to be off-trail above the tree line, okay? And the third rule is the silly salmon rule. You are not a fish. Therefore, any stream crossing not on a trail, okay, where there would be a bridge, will add 15 minutes to your total time for that segment. Okay? Because in reality, okay, if you are going to go across a river and you're going to be backpacking, what you would probably do is take off your boots, take off your socks so they don't get wet, okay, and then go across in like wading shoes or something like that, okay, rather than risk getting your feet really wet and then getting blisters. I don't speak from experience at all. Okay, you don't want to have wet feet at the start of a day where you're hiking 30 kilometers, or you will have blisters the size of a toonie, okay, on each foot, both sides, by the end of the day. Not fun, all right? Okay, so do those three rules make sense? All right, so the things to keep in mind. All right, so the second part of this activity is for you to practice using your kinematics skills and formulae. So for each day, you need to measure the total distance traveled. Now, that can be a bit difficult, okay? So let's say we're looking here at this path that I drew. How am I going to measure how long that is? Like, how do you get a ruler on all the curvy parts? You don't, okay? You can use anything that can take the shape of that path to help you measure it. A shoelace, headphone cable, okay, charging cable if you have any stuff like that. If you've got a drawstring in your hoodie, you can pull that out, okay. Any of those things will work. You just put it along so it takes the shape of the path, and then you pinch this end and that end, straighten it, put it on the ruler. Okay, now you've effectively measured all the curvy parts. Yeah, crazy. Okay, but it works really, really well. All right, so that's how you'll measure the distance for anything that's not a straight line. Okay, other things that you have to show. Okay, so that'll be your distance traveled. Okay, and it says here using a string and use a scale. Okay, you will also need to calculate your total time that you will be on trail. Now, here's how you're going to calculate that. So if I'm looking at this map here, okay, I would actually probably draw this slightly differently. I'm going to leave it green where I'm below the tree line, and I'm going to change it to blue where I'm above the tree line. Because on these parts that are blue, I'm walking at, well, since I'm not on a trail, 1 meter per second. These places that are green where I'm not on a trail, I'm walking at 0.75 meters per second. So for each one of these sections, I have to do a V equals D over T calculation where I calculate T. Okay, so I take that distance that I measured there in blue and divide it by how fast I can walk that, and that will tell me the time for that part. All right, that makes sense? So you'll have to do that for the 4 different speeds that you have, also factoring in any place where I cross a stream, not on a trail. 1, 2, 3. I think that's it. Okay, I got 3 stream crossings, so that's another 45 minutes to add to my total time for the day. All right, everybody follow on that? Okay. All right, so you got to calculate your total time for the day, okay? And you'll need to calculate your average speed. Well, that's just once you have your total time, okay? Take your total distance, divide by total time, and you'll have your average speed. You'll also need to calculate your displacement. Well, the displacement's a little bit easier, okay? Because the displacement will be a straight line. All right, so to get my total displacement, that's going to be the straight line distance from beginning to end. So I'll just take, well, you guys will take a ruler because you'll actually do this on paper, okay? All right, there's my displacement. All right, so I have a line that now represents my displacement. All I have to do is measure it, okay? But I also need a vector on this. So I've got to get a vector by doing the following. Right? I've got to have a y component and an x component. Since this went southwest, I'm going to have a y component that is south. So about like that. Okay, how do I know that's south? Okay, there's grid lines on the map. All right, so use the map to draw your line, your components parallel to the grid lines. Okay, and then I'll do a similar thing here to get the west component that's close, but it's slightly off. Okay, now I have x and y. I can measure them, and that will help me to get my angle here. All right, making sense? All right, so you got to get your displacement for each day, and then once you have your displacement, the expectation is that now you can also calculate your velocity for the day. Okay, so for each day, I'm going to want to see the distance traveled, okay, the total time. I'm going to want to see the average speed, the total displacement, and the average velocity for the whole day. Okay, so those calculations will have to be shown, and that stuff will have to be drawn on your map. Okay, so what I want to see, hand it in. Calculations of distance, speed, displacement, velocity, and time for each day. Triangles drawn on the map, as well as paths or directions you traveled, including vectors. Okay, calculations of total distance, total displacement, and total time on trail. Okay, only count your traveling time, not time spent sleeping. Okay, and average velocity for the entire trip. Okay, so basically you're adding stuff together. It's not as difficult as it sounds. Okay, so I want those for the entire trip as well. Okay, your group will hand in your map with your calculations. Okay, and like I said, an easy way to keep things straight on the map is to color code the sections like I did on that example there. Okay, if you're on the trail, you know, blue for under, 1700, whatever you want to use. Now, an important thing in terms of scale, because you need actual measurements. I don't want this in centimeters. The scale of the map is 1 to 50,000. That means 1 centimeter on the map is 500 meters in reality. So all of your calculations should be in meters, okay, not in centimeters. So you measure it, okay, if it's 5 centimeters, then it's 2.5 kilometers. All right, well, 2,500 meters, because we're gonna have this in meters and seconds. Okay, so I'm gonna want everything in meters and seconds, times and seconds, all that kind of stuff. Okay, it'll be out of 20 marks. Okay, 15 of those marks are to do with your map and calculations. So, you know, the quality of the routes you chose, you know, did you calculate everything correctly, all of that kind of stuff. And another 5 marks is for how well you worked as a group. Okay, if I had to, you know, pull you off of each other kicking and screaming, that 5 marks will deteriorate quickly. Okay. Similarly, if I'm constantly having to retask you because you can't stay on task, that will also affect your group mark. Okay, it's 5 marks out of 20, so it's not insignificant. All right, so questions on what you're going to be doing there? It takes a while because you got to get everything built and you got to draw everything and do all your measuring. So it's tedious, but it's not like difficult stuff. Okay, here's where people typically lose marks on this assignment. They forget things. Okay, I've told you what I want to see here. Okay, distance, displacement, okay, all those kind of things. Remember that displacement and velocity are vector quantities. If you don't have vectors on both of them, you will lose marks, especially since displacement and velocity for the same trip have the same vector. Okay, so it's senseless to forget it on one when it's exactly the same number. All right, so don't forget things like vectors. All right, and again, show your calculations as well. This is going to be handed in on paper, okay, not through Google Classroom, so keep everything. Suggestion, because this is going to be done as a group and you're working on it tomorrow as well, it would be advisable for each group member to take pictures of their map and possibly their calculations, just in case whoever is actually holding the physical copy of the map ends up not being here tomorrow. Okay, then you're not completely screwed. Okay, in terms of, oh, we don't have our map now, we can't do anything. Okay, at least you'd have the picture. I can give you another map, and you could, you know, do the next section or whatever, and then combine them later. All right, but at least then everybody has a copy of it. In the worst case scenario, we could print it again. Okay, as long as you have a picture of it, we could make another copy. All right, so advisable to do that at the end of the day today. All right, so the maps are over here. Okay, so once you've decided on your groups are 2 or 3, no bigger than 3, please. Okay, just make sure everybody gets a group. And if you're not in a group, I'll help you out with that. But we'll send one member of the group over, and I will hand out the maps to them. Okay.